We are now into lesson 7.3 or section 7.3 in the textbook, where we are going to look at the addition and subtraction of rational expressions that have least common denominators. So for this section, we're looking at adding and subtracting rational expressions with that have common denominators. What makes this part easy is we don't have to worry about trying to get a common denominator for this. So really what it comes down to is simply being able to combine the like terms correctly on the top and then taking the result and seeing if there's any simplifying that can be done at the end. It does get a little tricky when we have to distribute a negative, and we'll take a look at a few examples to kind of illustrate that problem and go from there. So we're going to start with some very easy ones to just get us going here. And this is going to be question 6 from the textbook. And we're going to take a look at the problem of 4 over a to the second plus 9 over a to the second. So we see in the problem that both denominators are the same number. So we should be, or both not the same number, but the same expression. So all we're going to do is simply write this as 4 plus 9 over a to the second, and that will give us 13 over a to the second. And in case you're wondering why we're able to write this over the same number, just kind of illustrate with a simpler example. If I were to have 1 over 10 plus 7 over 10, I would be able to write that as 1 plus 7 over 10. I can make that 8 over 10. Now, what's an important takeaway here is if we look at each fraction individually, we notice that we can't reduce it all. However, when we take a look at the resultant fraction, we realize that there is in fact some reduction that can take place at the end of the problem. And we'll speak to this in some examples later. Well, I can write 10 as 2 times 5, because 2 times 5 are factors of 10, and I can write 8 as 2 times 4. Now, I could write 8 as 2 times 2 times 2, but that's not really necessary because we only have 2 times 5 below, so we only need to reduce the 2's. So our final answer to this would be 4 over 5. Unfortunately, the factoring that we're going to be doing is not going to be quite this simple, but the principle applies, is that we can take two fractions or two rational expressions, not be able to reduce them at all in the process, but once we add them together, their sum, or in another possibility, their difference may yield a rational expression that can in fact be factored and reduced, like we have here. So let's go ahead a little further and let's take a look at an example involving subtraction. We'll take a look at number 12. So this is going to be 9 over 2x plus 3 minus 5 over 2x plus 3. So one way I'm going to go ahead and rewrite this, since I have a common denominator, I'm going to go ahead and write this as 9 minus 5 over 2x plus 3. And then finally 9 minus 5 will be 4 over 2x plus 3. At this point I look at the denominator and I realize that we can't factor it, and it doesn't divide into 4 at all. So this is going to be our final answer for this question, and there's going to be no further reduction here that will be necessary. Let's take a look at number 16, an addition problem, and see what result we get from that. So here we have 3a plus 13 over a plus 4 plus 2a plus 7 over a plus 4. So what I'm going to go ahead and do is, now you don't have to do this every time. You could very simply combine like terms. In fact, let's go ahead and do that. So if I have, no, let me do it the other way. I apologize, guys, but I am going somewhere with this, so I want to make sure to try to be consistent. So I've got the quantity of 3a plus 13 plus 2a plus 7 all over a plus 4. Well, when I combine my like terms, 3a plus 2a is 5a. 13 plus 7 is 20. And that's going to be all over a plus 4. So this is what I get, and that's my tentative final answer. However, when looking at this, I realize I might be able to factor that top after all. So I'm going to go ahead and I'm going to rewrite that down here. And I realize that from here I can factor out a 5. When I do so, it's going to give me 5 times the quantity of a plus 4. I do that how? By factoring out the greatest common factor. That's going to be over a plus 4. And now that I take my solution and I factor the numerator, I see that in fact there is a common binomial in the top and bottom, leaving me with a final answer of 5. And that's it. That's our final answer here. So one element that can make this potentially a little complicated will be that when you are doing your addition, nothing will simplify in that process, like it did with multiplication and division, for example. However, the final result may yield a solution that is factorable and can lead to further simplification, much like what we had 1/10 plus 7/10. Let's take a look at another example where we can use this and see why organizing information together could be helpful in obtaining a final answer. So we're going to go ahead and look at question 18, or 18 is good for this. Okay, so we'll take a look at 18, and that's going to be 3a plus 13 over a plus 4. This is when you can tell the authors are getting a little lazy, because I think they just took the question we just did and they went ahead and they just took a subtraction sign to it. But not a big deal. Question looks really similar. They just changed. Yep, pretty much the same question except with the subtraction sign. So what does this look like with subtraction? So I'm going to go ahead and write this down here below, and I'm going to make this a plus 4. We now have the quantity of 3a plus 13 minus the quantity of 2a plus 7. So another area that can sometimes be not real difficult but tricky is when we are subtracting a quantity, we have to distribute the negative through. So in doing that, I'll go ahead, 3a plus 13. One technique I have for this is I go ahead and I make this a plus sign. But in doing so, I have to make everything on the inside negative. If 2a is positive, I write this as negative 2a. And 7 is positive, I write this as negative 7. From this now, I'm going to go ahead and I'll combine like terms. 3a minus 2a is equal to a. 13 minus 7 is equal to 6. And I'm left with an answer of a minus 6 over a plus 4. This is the answer in simplest form. There's nothing that can be factored or reduced top to bottom, and that will be our final answer in simplest form. So there are two aspects, or there are two things that can make this a little tricky here. So one of them is when we are doing subtraction, we have to distribute the negative through the top. And that's an important note to remember here. The other thing that can make this tricky is when we get our final answer, we may have to do some reducing of that answer to get the answer in simplest form. And that's how we always need to express our final answer. Let's go ahead and take a look at one more example involving subtraction, and let's see what we get. This will be question 21. So this is going to be x squared over x plus 2 minus 6x minus 8 over x. And guys, I wrote this incorrectly here, so I wanted to change this x plus 2 to x minus 2. So I'm going to make this an x minus 2. Now, you don't have to show this step the same way every time. I just do this for the purpose of the lesson. I'm going to put everything over x minus 2. So it'll be x squared minus the quantity of 6x minus 8. So what I'm going to do is I'm going to make this a plus, but I'm going to switch the sign of everything on the inside here. Let's see what impact that has. So That's going to give me x squared plus this 6x is going to become negative 6x. This negative is going to become positive 8 over x minus 2. And again, I know I'm probably doing this a little overkill, but I'm just illustrating the point. When we have these two signs together and they're opposite, we can go ahead and write this now as x squared plus a negative will be minus 6x plus 8 over x minus 2. So, we see this answer here. Yes, it can be simplified. So this problem contains both elements which I've categorized as being kind of tricky about this process. We do have a distraction or a subtraction, which we have to distribute through the second numerator, the second fraction, and we are going to have to take this now and simplify it. So let's go ahead and write this below. Because we have a trinomial, that trinomial will need to be factored into two binomials, which, since I have a product of 8 and a sum of negative 6, my two factors are going to have to be x minus 4 times x minus 2. Negative 4 times negative 2 gives me positive 8. Negative 4 plus negative 2 gives me negative 6. That's going to be over x minus 2. Because I have common binomial factors here and here, I can reduce that and get my final answer of x minus 4. And that is my final answer in simplest form. We're going to go ahead and do a few more practice problems just to kind of show you a few of the curves that you may encounter in doing questions like this. Although generally speaking, these questions are not the most difficult problems, and this is not a terribly long section. So let's go forward with a few more questions. Let's take a look at another addition problem now. Looking at question 26. So this will be x minus 5 over x squared minus 4x plus 3 plus 2 over x squared minus 4x plus 3. Again, these questions are not terribly difficult because the denominators are the same. You'll see in section 7.4 we won't be so lucky. So we can simply take the terms that are like on top, like we have a negative 5 here and a plus 2 here, and I can just write these together as x, negative 5 plus 2 is minus 3. So now I'm kind of taking a shortcut and skipping that step, and I'll write this over x squared minus 4x plus 3. Now we look again and we see if we can factor anything. And as it turns out that this trinomial is likely going to factor into two binomials. Well, since we have an x minus 3 at the top, it's probably a good idea to look for x minus 3 being one of the factors below. And in fact, we can write x squared minus 4x plus 3 as x minus 3 times x minus 1. Again, if you're having difficulty with some of these types of factoring, please look at the review sections that are included for this class, particularly sections 6.2 and 6.3. 6.2 covers this type of factoring quite nicely. So, when we get to here, we recognize that we have x minus 3 as a common binomial factor top to bottom, and that will give us 1 over x minus 1 as our final answer in simplest form. So, we see here that we had a problem. We simply added the top, or added the numerators, and we got a binomial, which when we factored the denominator, led us to that we could reduce top to bottom and led to a further simplification of the answer. Let's go ahead and take a look at just one more problem for this section. We're going to go ahead and take a look at question number 32. This would be 2x squared plus x over, guys, this is going to actually be 31. This is the one I'm copying down right now, so let me not be confused. Question number 31. Over x squared minus 8x plus 12 minus the quantity of x squared minus 2x plus 10 over x squared minus 8x plus 12. Based on some of the work that you may have done in chapter, or in section 7.2, you may be tempted to try to factor some of these right away. What I'm telling you to do is just go ahead and wait, and let's see what happens with this first. So what I can do with this problem now, instead of rewriting the whole fraction, I'm going to go ahead and make this a plus, but in making this a plus, I'm going to change the sign of everything on the inside. So what was positive before is negative now. What was negative will be positive, and what's positive is going to be negative. Now, if you want to write this as a separate step, please go back and stop the video so you can show what this looks like before, and then rewrite it for yourself so that you can keep your work more consistent. So we're going to go ahead and see how the top simplifies and see where we can go from there. So we have 2x squared minus 1x squared. That should be x squared. We have a positive x and a positive 2x. That should be positive 3x. We have nothing here, and we have a negative 10 here, so we're going to go ahead and write that negative 10 there. So it appears as if we have left on top x squared plus 3x minus 10. So let's see if we can factor the numerator and denominator of this to yield something that will help us to reduce it. So for x squared plus 3x minus 10, I can write my pair of factors here as x plus 5 times x minus 2. Again, I'm not concerned about the factoring techniques for this section. At this point, you should be comfortable with the factoring. If you need to do the work, that's fine, you can do that. But no, that is already covered in Chapter 6. I just go straight for the factors to focus on the technique in this section, not the factoring itself. For x squared minus 8x plus 12, the two factors that will give this will be x minus 6 times x minus 2. Because negative 6 times negative 2 is positive 12, and negative 6 plus negative 2 is negative 8. When I reduce the x minus 2, the top and bottom, we should get a final result for our answer in simplified form to be x minus, or x plus 5 over x minus 6. Again, this section is not one that is terribly difficult, nor does it have a lot of homework. We're going to go next to section 7.4, where the work gets rather complicated. See you there.